We have a 2015 Ram 3500 with the Cummins diesel, and it's here for, well, he brought it here primarily because his four-wheel drive doesn't work. Let's turn it on and see what kind of messages we got. Service four-wheel drive, check engine light on, stability control light on, and he also mentioned that his trailer brake system doesn't function properly. And I asked him if it was integrated trailer brake, and he said yes. Where's the trailer brake control? Oh yeah, there it is. I just operated the trailer brake control, and it says rear park sense service, rear sensor, water and fuel. This thing's full of fun. Well, we'll put a scanner on it and see what it's got to relay to us in the form of fault codes in the various controllers. So this is a new vehicle record. I've never scanned it before. It auto-ID'd it as a 2015 Ram 3500. I should be able to do a network scan with the key on, engine running. How come it says automatic VIN not supported? It's got the VIN. Display fitted systems. Let's do a code scan. Pre-scan. And survey says lost communication with master power window. Where's the ECM? How come it didn't scan the ECM? Driver's door module. This is all a different network. Heating and ventilation. That's interior CAN. Wow, isn't that special? What do we get? Yeah, it scanned the OBD2 side of the computer. Isn't that weird? Well, let's go into the PCM manually. No communication with the PCM. So we might be dealing with a network problem on this. As I noticed it didn't... Wait a minute, where's the transfer case? Going into the transmission controller. No communication with the transmission controller. That might be the PCM on this thing though. I'm going to fire up the Think Tool. So I'm going to try this Think Tool Pro Plus. Let's see if it'll auto-ID. Now the snap-on scan tool may have pulled it out of the OBD2 side of the ECM. Let's see if this does. Yeah, it auto-ID. Chrysler EV, Chrysler. What if it's none of those? Let's try this one. It's not an EV Chrysler. I thought Ram was its own entity after 2011. Okay, 6.7 diesel. Let's do a smart scan. So that's communicating with the PCM, that's communicating with the BCM, IPC, ABS. What's going on with the snap-on scanner? Does it say 18 codes? Wow. Let's look at the report. Closed loop reductant injection control unit at limit, engine control module, power input, signal intermittent, turbocharger boost control, water and fuel, lost communication, turbocharger boost control performance, lost communication with ABS, lost communication with transfer case, lost communication with body, lost communication with steering column, lost communication with radio frequency hub, selective catalyst reduction, NOx catalyst efficiency below limit, exhaust gas temperature sensor circuit intermittent. Like this, what code doesn't it have? Invalid skim key, CAN C bus performance, some lights, wow, CAN C bus. Yet this thing communicated with the modules and pulled the codes out of them. I wonder if this has got, I see that it's got electric power steering rack. I wonder if it's got water in the power steering rack. It's a drivetrain transfer case range, digital position sensor performance, transfer case motor control circuit open. Now he threw a motor at this thing hoping that it would fix it, so he may have generated that code by having the key on and the motor unplugged. Sensor supply voltage high, all-wheel drive circuit, clutch power control circuit, radio, speaker code, driver's door module, lost communication with switches, passenger door module, mirror approach light control circuit. Well, I think before we get too carried away here, I've got a record of this, so I'm gonna do a network code clear. But I gotta do that key on, engine off. So I've got the key on, engine not running. I'm gonna do a network code clear and then we'll rescan it. All right, it's not running. Let's try scanning it one more time. Two codes in the PCM, one in the ABS, one in the drivetrain control module, one in the radio. Let's look at this report. Water and fuel sensor, NOx exceedance, deactivation of EGR. It's probably tuned. ABS code, implausible data received from transfer case, and here's the transfer case. Transfer case range digital position sensor performance. So this is the one we're chasing. C1480. Integrated trailer brake module. It's hard to say, there's no codes in it, but that's what he said. He had messages on the dash for service trailer brake, or maybe it's just a wiring problem he had on the dash. He's mentioned he had a problem with the 7-pole plug at the back and he fixed it or changed it, but he had to fix some wires. So we're going to investigate the C1480 to start with, and then I'll talk to him about the implausible data received from the transfer cases secondary, and this PCM codes. He didn't mention anything about the check engine light So his major concern was the transfer case on that C1480. So I tried the snap-on scanner a second time because it bothered me that it didn't communicate. But when I went to display fitted systems, for some reason it didn't pull up some of the modules on the bus. So I didn't click on display fitted systems, I clicked on display all systems. And we got the same codes now: ECM, BCM, ABS, license plate light, minor, mirror approach light, minor, driver's door. But the C1480 is an active code. So let's go into the drivetrain control module and see if Snap-on has any troubleshooter information. No, they don't. So we'll look it up. So I loaded the VIN in Identifix and I typed in the keyword search C1480 and transfer case shift motor wiring, transfer case shift motor mode sensor. So we're going to put it up in the air and have a visual inspection on it. Here's the troubleshooting chart from the factory. Runs continuously, no system under voltage code, excessive voltage fluctuation, drivetrain 5-volt supply circuit shorted to voltage, 5-volt supply circuit high resistance, drivetrain 5-volt supply shorted to ground, transfer case shift motor mode sensor assembly. So the code resets instantly as soon as I clear it. Disconnect transfer case shift motor sensor assembly harness connector, start the engine, measure the voltage on the K504 drivetrain 5-volt supply circuit. Just tell me what causes the code to set conditions. Excessive voltage fluctuations on the transfer case mode sensor signal circuit. Well, let's have a look at the circuit. So down here underneath, looking at this transfer case, I took the skid plate off and one of the bolts was previously broken and I broke one off, so we'll have to put some self-tappers in there. But that doesn't look like a new transfer case motor. That looks like a previously enjoyed one. And what the heck is this wire going into the transfer case for? I don't know what that's all about. That's odd. It's been spliced. I don't see anything obviously wrong, but it's spliced on the harness side, so he must have cut that and spliced that wire. Because that's on the harness side, or on the motor side of this. So I'm going to ask him to bring me the original motor tomorrow, because he switched out the original motor for this one, and I assumed when he said he changed it that he put a new one on, but that definitely isn't new. So sometimes we're installing a used part that's already got a problem in it. Suppose we could check the circuits up to this. But I'd rather start with the original motor and ask him if he spliced this wire as well. So looking at this case on Identifix for the P1480 code, it mentions that there are four switches, and it says using a scan tool, look for read digital encoder channels test under the miscellaneous function in the drivetrain control module. If this option is not available, on your scan tool, voltage can be measured with a voltmeter after shift motor mode sensor connectors. Well, I'd rather do it with the scan tool, so I'm going to see if the scan tool supports this. Drivetrain control module, miscellaneous functions. No. Functional tests. Power supply. Let's see if it's one of these tests. No, that's front axle disconnect. FAD is front axle disconnect. So I don't see it with this snap-on scan tool. Feedback's FAD signal, FAD power supply, transfer case motor duty cycle, transfer case motor lock, transfer case service indicator request, So it appears this scan tool doesn't have the capability, and I looked in the data list and I don't see it in there. It says read digital encoder channels test under miscellaneous functions in the drivetrain control module. I've looked through this data list a couple of times and I don't see encoder motor feedback signals. And it's not under the miscellaneous functions here. And ECU information is not going to give it to me. That'll be just serial number and part number. So I'm going to fire up the Think tool again and see if it'll do it. So now we're using the Think tool Pro Plus. Drivetrain control module. Let's do special functions maybe. Read digital encoder channels. Snap on for the fail. Four 4.1, 4.8, 4.9. Channel 0, 1, 2, 3. 4.9, 4.9, 4.1. They don't change by much. My understanding is, well, if we look at the service literature in the information system here, let's put this off to the side and go back to the software. When the encoder motor is in two-wheel drive, when the transfer case motor is in two-wheel drive, the voltage is read channel 3, 4.5. Channel 3 is 4.9. Channel 2, 4.9. Channel 2 is 4.88. Channel 1, 4.5. That's correct. Now I got 4.1. And channel 0 is 4.5. None of these match. The only one that matches is channel 3. And I'm assuming it's in two-wheel drive right now because the front drive shaft spins free, but I don't know for sure what range it's in. I wonder why I can't print this. Print this. Doesn't print. Let's click print preview and see if that'll work. Let's go Control P. Why is that grayed out like that? I'm not going to print that because I'm going to use up half a toner cartridge doing so. So I used copy and paste and I printed off what it's supposed to be. But I'm not sure if it isn't actually in two-wheel drive. So I'm going to go back out and look at the status. Data stream. Drivetrain control module reason. Front axle disconnect. Transfer case motor current. Transfer case status. What does 7 mean? Actual mode of transfer case clutch. Just select all. Let's go down the list. Drivetrain sensor supply voltage is 4.08. DTC, drivetrain control module, internal DTC reason, German. Interesting. Front axle disconnect switch is disengaged, two-wheel drive. So I think it's in two-wheel drive. Outside temperature 205 degrees. I don't think so. Right rear wheel RPM. Transfer case service indicator request true. Transfer case status 7. Transfer case type 2. Four-wheel drive lock part-time lap request off. Low request off. Neutral off. Transfer case shift request status two-wheel drive. So I'm pretty sure it's actually in two-wheel drive. So under special functions, then read digital encoder channels. Motor 1, channel 1 should be 4.5 and it's 4.1. So I'm going to circle that one. That one's off. So only one of the channels, channel 2, is reading correct. It's supposed to be 4.9 and it's 4.88. But this one is supposed to be 4.5 and it's 4.88. This one is supposed to be, channel 1 is supposed to be 4.5 and it's 4.1. And channel 3 is supposed to be 4.5 and it's 4.9. So let's look and see how this thing is wired. Look at the circuit for this. So according to this, it says if the voltage is on one or more but not all of the signal circuits do not match with the voltages in steps 3, 4, 5, and 6, unplug the shift motor mode sensor and check voltages on the 4 signal wires. All should have 4.9 volts. Key on engine off. Well, I've got a clean battery charger on it, and I'm going to unplug it, and these should all go to 4.9 volts. And if they do, that would indicate that the shift motor is bad to me, but it could be that there's a bad wire. So I've got the shift motor unplugged, and all 4 read 4.88 for mode 1, channel 1, 4.88 for channel 2, 4.9 for channel 3, and 4.88 for channel 0. So let's read what it says. It's the measured voltages. Voltages on the scan tool show all the time, and the measured voltages. Let me read some more. So I've got a pinout of the connector at the motor. Pin A is supposed to be drivetrain control computer 5 volts, and I've got 1.78 volts. So that pin is compromised. That's the brown wire. Pin B is encoder signal 0, and that should be 4.9 volts according to my understanding, and that's what we have. Pin C is encoder signal 1, and that should be 4.9 volts, and that's what we got. Pin D is shift motor control, and we've got 0.54 volts on that circuit. Pin E is shift motor control, so that's across from A, and that's greater than 5 volts. Let's see what the voltage is. Or greater than 10 volts. 11.59. pin F, switched battery power. I don't know what that one, let's see where that one comes from. Switch battery solenoid supply, pin F, and I've only got 3.73 volts on it, so let's see where pin F comes from. I gotta turn my headlight on so I can see these schematics. EF. Well, that comes from the drivetrain control module. It doesn't switch battery stuff. Okay, well, that might not work until we have it running, so I'm not going to focus on that one too much. And G and H are encoder signal 3 and 2. So this should be 4.9 volts. And that one's 0. So that's a problem. Yet on the scan tool it shows 4.9 volts. And G, that's G, and H should be 4.9 volts. And that's okay. So the 5 volt reference, and again, I'm not sure if that 5 volt reference will be there with it not running. I might go up and start it and see, because sometimes these modules don't output a voltage unless they're running. That's pin A, drivetrain 5 volts. I'll read the troublemaker chart. Drivetrain 5 volt supply. There is a connector in the circuit according to the schematic. That would be the next logical place to go to. It's an inline connector. Engine transmission is probably up by the bell housing of all frickin' places. I've had problems with that connector before. Sorry for the glare, but I can't see under here without the headlight. So we have some direction. We probably have a wiring problem. I'm going to try using a test light. There's no ground on this shift motor. That's odd. It must ground through its mounts. There's one wire coming off the shift motor that is spliced. Goes into the back of the transfer case. I gotta figure out which one that is. So the challenge is to find this connector. Chrysler no longer numbers the connectors, they name them. So this one's named the inline dash engine transmission connector. And it's quite a big connector because it has a large number of pins in it. Normally you would go to connector views and you would search for the connector. I know on their information system that is a hyperlink. OEM connector views. Connector details. So there's 2,222 connector diagrams. You're not going to look through them individually. So I type in the word inline and enter. And there are 8, but none of them are in there. Inline fuse, fuel injector, headliner. All right, let's try searching for inline like this, in case that makes a difference. Solenoid short runner, no. When I went inline, so inline dash engine transmission connector, but I click on that and it says it's not there. Did you mean inline dash engine transmission connector? Maybe let's try that. So that didn't work. I've searched through this thing for 45 minutes now looking for a picture of that connector and the exact location of it. There is one connector up by the bell housing, but that one doesn't appear to be the right one. So now I'm using an all data information site. It has the same OE diagrams, but there's no hyperlinks. Normally this would be a hyperlink if you were on Chrysler or Stellantis service information site. So I'm going to see if they have connector views. I know they do. Let's go back. Connector views. 182 connector views. What was wrong with numbering the connector? Engine control module. These are connectors at the actual components, not inline connectors. Wow. I'm going to look around some more. I'm going to buy a subscription to Chrysler's service library. Please log in using your credentials. Dealer code is required. I got to figure out how to do this again. So I'm on the Stellantis service library, and I punched in the VIN number and it shows a bunch of recalls outstanding on this thing. Engine calibration, selective catalyst reduction, truck drag link, tailgate latch. So there's several open recalls on it. Here's the optional equipment. So let's go down to service information. I had to reset my password, then I had to wait for electrical. Let me find this diagram. This bloody truck is fighting me tooth and nail. So this is the service information right from Stellantis. C1480, there's the schematic. There's the connector I'm looking for. It's not labeled, so there's no hyperlink. I'm looking for the wiring diagrams, for crying out loud. So under electrical, it has audio, video, chime, buzzer, engine, battery, starting, charging, ignition, instrument cluster, lamps, lighting, power, speed control, vehicle theft, wipers, and navigation. It's not there. Transmission and transfer case. Transfer case BW Borg Warner 4446. I'm pretty sure that's one we have. Diagnosis and testing. Disassembly shift motor. Description and operation. Diagnosis and testing. Why can't you just give me the damn electrical schematics? Body. Why do they have to make it so bloody hard? So I did a keyword search for inline dash. Let's see if that shows where it is. Inline dash body. That's not the one we want. We want inline dash engine transmission. Yeah, that's not the right one. Inline dash engine transmission. Okay, let's go back. Enter. Inline dash connector. Standard. Inline dash IP connector. Inline dash connector. All right, let's try engine. Inline dash engine transmission. Why didn't it pull it up? So that is quite a large connector, inline dash engine transmission. Let's see if that concurs. Looking at the schematic, I gotta put my stronger glasses on so I can see these numbers on these. $12, $13, $9, $25, $25. Let's see. Pin Pin 5 is drivetrain 5. I'm using the camera as a magnifying glass. Pin 5. Let's see if that concurs. No connect. Except electronic transfer case. Oh, I see. Brown wire, 18 gauge, drivetrain 5 volts. So this is the right connector view. So this is what we're looking for. That's not the connector I saw. That's a big latched connector. So I'm going to see if I can find that now. I wonder if it shows where it is on the vehicle. There's a lot of wires running through there. And the other wire that was compromised was, or that in question was pin G. EFG, that goes to pin G, transfer case encoder signal 3 goes to pin 13. 13. Yellow, dark green. Yellow, dark green. Okay, so at least we know what kind of connector we're looking for now, because I saw a connector up on top of the transfer case, or up on top of the transmission, but it didn't appear to be that one. My trouble light went out. There's a connector way up there. I'm gonna get some more lights. My lights have all gone dead. So there's that main connector, inline dash. I have the voltmeter connected to pin A down there, and I was reading 1.7 volts until I disconnected this connector. So one of these harnesses goes down and one of them goes into the body. So this is the body side here. This is the harness side going down to the transmission. I tried wiggling the wires here and it wasn't making any difference. So I'm going to figure out which pin in here is the 5 volts. If I could unclip this from this harness, from this bracket, would be nice. Pins look clean in there. There's no signs of corrosion, and I monitored the voltage while I wiggled the connector, but I didn't change. So I'm going to figure out which pin is number 5, I think it was the 5 volt reference. So checking on this side of the harness, which appears to come from inside the cab, and although this harness looks like it goes down, it looks like it goes to the cab. This one's got the ignition power on pin 8, but the inline connector that we have disconnected interrupts power, so I have to back pin these wires. So I'll have to take the plastic cover off the back of this connector so I can plug it back in and back pin it here. So the male half of the connector with the harness running down towards the transmission is the one going back to the transfer case, and I've got it on pin 5 and pin A of the transfer case motor. That's the 5 volt reference, and I got no resistance. I got continuity through that wire, but I'm going to check it for a short to ground. So with the connector plugged back in and back pinning pin 5, I'm measuring the same voltage I measured down below at 1.78 volts. Let's check that encoder 3 signal. That was pin encoder 3 signal is encoder 3 signal 2 2 signal, pin 13. Yellow, dark green, and on this connector it's almost below pin 5. Let's try that one. So I'm back probing pin 13, which is the yellow, dark green wire, encoder signal 3, which was only 3 volts down at the bottom. It's 4.9 volts up here, but yet down at the transfer case motor is 3.73 volts. So somewhere between here and there, that wire is compromised. Oh, brother. I look for places where it rubs through. There's a rub mark on this bracket here. I'm going to explore that. So I ran a jumper wire, back pinning pin 13, which is channel 3 signal, to pin G, and I've got a measuring voltage of 4.13 volts down there. Yet on the scan tool, it shows encoder 3, 4.9 volts. Let's remove that pin. So I'm going to disconnect my jumper wire and see if the voltage changes. Disconnecting now. And it didn't change. That doesn't make sense. I'm going to check continuity of the wire from there down to pin G, but I'm pretty sure I had an open circuit. I'm starting to lose track of what I did. Need to step back and take a break here. So I did continuity tests from the connector at the transfer case motor, pins A through H, to the appropriate pins at that connector. And the only pin that tests open is the transfer case encoder signal 3. These 2 pins test opposite. This one, pin D, says it goes to pin, let's see what it says here. D goes to 25, but it actually has continuity to 26, and E goes to 25, which says E is 26 on here. And I looked, the color of the wires is yellow and brown and yellow and gray, and that's the way they're pinned in that connector. So I don't think they're mixed up because nobody's been there before. But I bypassed this circuit. I back pinned a pin into pin G at the transfer case encoder signal 3 and jumped it from pin 13, which I believe was transfer case encoder signal 13, 3, I can't read this. Okay, transfer case encoder signal 3, which is pin D, sorry, pin G for George, and it goes to pin 13 at that inline connector, and I have no continuity, so I jumpered between those 2 pins. So that's what I did. I back pinned pin 13 at that inline connector, and I jumped power that circuit to pin G at the transfer case motor. Now I didn't clear the codes, I just looked at the data. Maybe I should have cleared the codes. So I'm going to try it again. So I got the circuit in question bypassed from 13 to pin G. Let's clear fault codes. Says still codes remaining. Read fault codes. I still don't have 5 volts on that 5 volt reference. Yet that wire tests good. So do I have 2 problems? This 5-volt reference doesn't read 5 volts, and I tried it running, but I have continuity from pin 5 to pin A, and it's not shorted to ground. I can't check for 5 volts there. When I back pin it, I read 1.7 volts, the same as I read down here, but I check to make sure that wire is not shorted to ground. So I spliced this, bypassed this circuit, and we still got the same fault code. We still got the same transfer case digital encoder channels reading wrong. According to that, what we had before was channel 0 at 4.88, channel 1 at 4.1, now it's channel 1 at 4.43, channel 2 at 4.88, and channel 3 at 4.45. And that's exactly what we had before. Yet channel 3's voltage of 4.9 volts doesn't measure down there, but it measures up at the top. So there's a wiring problem for sure, but there's got to be more to it. That 5-volt reference is also a concern. What is the likelihood of having two problems? So I'm looking at the factory troublemaker chart for 1480, and it says if the code returns, measure the voltage on the K504 drivetrain 5-volt supply circuit at the transfer case shift motor. Why call it a 5-volt supply if it's not 5 volts? Voltage should be approximately 1.7 to 1.77 volts and steady. Compare any slight fluctuations found to a no good circuit in order to verify voltmeter functionality. So that circuit is only supposed to measure 1.7 volts is what we have, not 5 volts, like it's called. Yes, go to step 8. And replace the transfer case shift motor mode sensor assembly. Well, he told me that this came out of a working truck, but I'm questioning. I know there's a problem with the wiring, but there's a problem with that motor as well, as far as I can tell. There's a compromised wire on pin G to pin 13 of the inline connector. I don't see continuity through it. I'm going to get another actuator and try it. So I replaced his used actuator with his original actuator, and I ran a temporary wire from the front inline connector to the connector at the transfer case pin G, from pin 13 to pin G. And I'm going to go into the drivetrain control module now and special functions and read digital encoder channels. Channel 0 is 4.8, that's what it was before. Channel 1 is 4.1. Channel 2 is 4.8. And channel 3 is 4.9. So let's clear the codes. 4.8 for 0, 4.1, 4.8, 4.9. Got the same readings. Let's try clearing the fault codes. Well, we still have the 1480 code. Now, did I mix up the wires or something? I did splice the wire temporarily Let me double check my work. So I double checked my work and everything looks normal. So unless this encoder motor has failed too, we're missing something. I'm going to go back and recheck the voltages at this plug now that I've got the wires. I got pin G jumped to pin 13 at the module, or at the inline connector. Yeah, pin G jumped to pin 13. Well, let's measure the voltages again. So the voltage on pin 1 is 1.78 volts, which is apparently the 5 volt reference. Why it's called 5 volts, I don't know. Voltage on pin, that was A. Pin B is encoder signal 1, and it should be 4.9 volts open circuit, and it is. Pin C is encoder signal, pin B is encoder signal 0, pin C is encoder signal 1, and that should be 4.9 volts as well, and it's not. Pin D is motor control ground. Pin E is shift motor power. F, switch battery source. Why is that only 3 volts? Pin G, which is the wire I got bypassed right now, is 4.9. If I take my wire off, it goes to 0. So we have 2 open circuits. How did I miss that last time? And transfer case encoder signal 2 is H, and that's 4.9. So this wire, pin B, C, should be 4.9 volts. Transfer case encoder signal 1. And all of those should go to 4.9 volts with the connector unplugged. So 4.88, 4.88, 4.88, 4.9. So the problem is we have another open wire. So we have 2 open wires in that harness. So I'm going to connect another jumper. So now I bypassed that second wire now. Channel 0 is 4.88. Channel 0 should be 4.5. Channel 1 is 4.43. It was 4.1 before. Channel 1 should be 4.5. So 4.43 is pretty close to 4.5. But the first channel 0 is off. Channel 2 is 4.88. It was 4.88 before, and channel 3 is 4.45. It was 4.9. So let's try clearing the codes. This one is still off according to this. Channel 0 should be 4.5. Let's try clearing the codes. Code still present. Read fault code. Oops, I hit the wrong button. Read fault code. We got a new code now. Read fault code. Of course, I had it disconnected. 1480 and 1404. Let's clear them. Okay, well that's a step in the right direction. Let's put the original used, the new used one in there again. Okay, so I put the used controller back on, the one that he bought. Let's see what we got now. Channel 0, 4.88. Channel 0 should be 4.5, so that's still out. Channel 1 is 4.43. Channel 1 should be 4.5. That's close enough. Channel 2 is 4.88. Channel 2 is 4.9, so that's close enough. Channel 3 is 4.45, and channel 3 should be 4.5. So this one is still out. So do we have two broken wires? I know we got two broken wires based on the voltages down at the encoder motor. Is the used controller or the used encoder motor defective? And the original one that was on there was defective as well. I don't know what the fault codes are. He said there was a piece of paper with the codes written on it, but interesting, since I put that jumper wire in there. Let's clear the fault codes. For pin C, and read the fault codes. We've got 1404 and a 1480. So I'm going to take that jumper wire off and see what happens. Let's try clearing the codes. Read the codes. How is it that we have two codes now when we only had one code before? I got a clean battery charger on it. This thing is just full of fun. I'm gonna burn this truck. So I tried another new Dorman transfer case motor, just temporarily connected it, and it didn't fix the problem. I know I have two compromised wires in that harness, so my intent is to make up a new harness with 8 wires in it. Now I don't have 8 identical colors, so I made a legend for my harness. So pin A is initially brown, goes to pin 5 at that inline connector. It is now going to be a black 18 gauge wire. I maintained the same gauge thickness. There's 6 18 gauge wires and 2 14 gauge wires. The motor wires are 14. Actually there's one 20 gauge wire, but I use an 18, which is a little thicker, so it won't matter. I made up a harness, taped up 8 wires. So we're going to splice it in there, and hopefully that's going to resolve it. I checked continuity between wires, and I didn't have any, but I am at a loss. I know there is 2 open wires. Pin C is open, and pin G is open, I believe. Yes, G. But I bypassed the circuit from the connector at pin 11 to pin C and ran a jumper from pin 13 to pin G, back pinning it, and it's still not working properly. So I'm going to cut out cut in this new harness, and hopefully that's going to resolve it. So I spliced in my new 8-wire harness from the inline connector, following this legend that I made up. pin for pin. I'm going to connect the connector up top and measure the voltages down here and see if they correspond. And then I'm also going to use a test light on the circuits that are the encoder channels and see if the voltage goes from 4.9 down to something other than 4.9 or 0. So I got the connector up top plugged in, and I've got the connector at the bottom unplugged, and I'm going to do pinouts on it. Pin A is the 5-volt reference, and it measures 1.78, and that's in spec. Pin B is encoder signal 0, and it reads 4.9. Pin C is encoder signal 1, and it reads 4.9. Pin D is shift motor control A, and it reads 0.5. I believe that's the low side. Pin E is shift motor control positive, 11.56. F is switch battery voltage to the solenoid inside the transfer case. G, which is one of the circuits that had a problem, is 4.99 volts. That's encoder signal 3. And the last pin, H, is encoder signal 2, and it reads 4.99 volts. Now, what I'm going to do is watch the encoder signals and make sure they correspond when I ground it out using a test light. So I'm watching the encoder signal voltages, and with the connector unplugged, they all read 4.88 to 4.9. So encoder signal 0 is pin B, so I'm going to touch it with a test light, and it goes to, that's the right one. Encoder signal 1 is pin C, and that goes to 0. Encoder signal 3 is pin G, and that goes to 0. And encoder signal 2 is pin H, and that goes to 0. So the wires are routed correctly. So let's plug this thing in and see what happens. So now it's plugged in. Let's see if the readings are correct according to the... Oh, I printed it off. I got to get this piece of paper. So now, reading the encoder channels, channel 0 reads 4.88, and according to the specs here, it's supposed to be 4.5. Channel 1 reads 4.5. Spec is 4.5, and it's 4.43. Channel 2 is 4.88, and that's good. Channel 3 is 4.45, and that's supposed to be 4.5. So this one's still out. So is the information incorrect? Let's go back out and clear the codes. Code still present. Oh joy. Now I do have that used transfer case motor on there, the second used one, the one he put on recently. (1404) and 1480 transfer case range position sensor circuit low. And 1480, transfer case range digital position sensor performance, active codes. I'm going to burn this truck. So both codes 1404 and 1480 are populating now. 1480 I had at the beginning, and now with the wiring repaired, I got 1404 and 1480, which I had after or before as well. Both of them relate to that 5-volt reference. So I got conflicting information. Here is the troublemaker chart for 1404. turn the ignition off, disconnect the shift motor sensor assembly harness connector, turn the ignition on, measure the voltage on the C1480 drivetrain 5-volt supply circuit at the shift motor mode selector sensor. Select the answer that best describes the voltage. Well, I read 1.77 volts. Below 4.5 volts, go to step 3. It says step 3. Check the C504 5-volt supply circuit for an open circuit or high resistance. It says disconnect the drivetrain control module connector 1 and check continuity of the 5-volt wire between pin 11. It's pin 11 on the drivetrain control module connector 1. Yeah, C1 pin 11, brown wire. So this is suggesting that it should be around 4.5 to 5.5 volts. Yet the troublemaker chart for 1480 suggests otherwise. It says, does it code return? Yes. Go to step 2. Check the voltage on the C504 drivetrain 5-volt supply circuit. Turn the ignition off. Disconnect the transfer case motor. Start the engine. Now this says start the engine. The other one said turn the key on. Now I had tried running it to see if it went to 5 volts with it running, and it doesn't. But here it says voltage should be approximately 1.71 to 1.77 volts and steady. So which one is it, Chrysler? Is it 5 volts or is it 1.77? I think what I'm going to do is let it down off the hoist, access the drivetrain control module, and measure the voltage at pin 11. If I've got 5 volts there, then I got a problem with this wire. I've run a new wire from pin 5 to pin A on the encoder motor, but there could be a problem in this circuit here. This thing is killing me. So I'm under the passenger side of the dash at the drivetrain control module, pin 11 on the brown wire, key on, 4.46 volts, 4.48 volts. Yet down at the actual transfer case motor, I have 1.78. I don't know what to believe now. The other thing that I found out is looking at this, it says in the connector view doesn't line up. That's wire insertion side, so the back side of the back view of the connector. But the wire on pin 9, there's one in 9. Yet on here it says 9 is not available. 10 is not available. I have no wire in pin 10, but I have a wire in pin 9. But the only brown wire in there is in pin 11. So is that wire compromised between here and the connector? I'm going to check it at the connector again. The inline connector under the hood. So back pinning at this inline connector, pin 5, the brown wire, I got 4.48 volts here. Yet I only had 1.7 down at the transfer case motor, but I got to lift it up to get underneath there to check it again. But I'm going to see if the code goes to history now. So now after cycling that connector C1 at the drivetrain control module, I got 1404 stored and 1480 stored. Let's clear the codes. Let's read the fault codes. Are you kidding me? The connector didn't look corroded or oxidized. Let's check the special functions again. Read digital encoder signal. Oh, I must have pressed cancel. Channel 0 is still 4.88. Channel 1 is 4.43. Channel 2 is 4.88. And channel 3 is 4.45. Let me compare that to the guide. So channel 0 is supposed to be 4.5 according to this technician tip. So that could be a typo. Channel 1, but I've got no codes. Wonder if I can command it. Let's read data stream. Actual mode of transfer case. Desired lock. I'll make a custom data list here. So according to the data stream, it says the actual mode of transfer case is free running. I'm going to try switching it. It switched to 4 lock. Switched to 2-wheel drive. 4 lock again. 4 low. Probably have to step on the brake pedal to get it into 4 low. I'm going to have a closer look at those connections. What did this go to? Well, it's working now. So I'm going to deoxidize those terminals at the transfer case, drivetrain control module, and then we'll button this thing up. Thank goodness. So here's the encoder signals in 4-wheel drive. Channel 0, 4.9. Channel 1, 4.43, Channel 2, 4.43, and Channel 3, 4.9. And that concurs with these steps in 4. Step 4, it says when the transfer case is in 4-wheel drive, the voltages read Channel 3, 4.9, Channel 2, 4.5, Channel 1, 4.5, and Channel 0, 4.9. But when it's in 2-wheel drive, this one stays at 4.8, and this flow chart here that somebody wrote says Channel 0 should be 4.5. So it's either a typo, but anyways, we've got it sorted out now. There was 2 open wires between inline connector and the terminal, and that 5-volt reference is actually supposed to be 4.5 volts, at least 4.5 volts. I don't know why that troublemaker chart for C1480 suggests that 1.7 volts is adequate. It's called 5-volt reference. You would typically expect it to be 4.5 to 5.5 volts. Oh well, we'll button this thing up and get it out of here.